Okay, through 34 through 37, basically we're just solving quadratic inequalities. So you can solve these quadratics any way you want. If you can factor it, factor it. If you just have a single x squared, like number 34 just has a single x squared, you can isolate it and take the square root. You can use a quadratic formula, whatever you want to do. But first of all, you just start off by solving it. So, as if it was an equal sign. So 16x squared is greater than 100. I'm going to divide by 16. So I get x squared is greater than 100 over 16, which I know that reduces, but here's when we'll leave it alone. If I take the square root of both sides, I get x is greater than plus or minus the square, plus or minus, which the square root of 100 is 10. The square root of 16 is 4. So plus or minus 10/4, which now I'm going to reduce it. X is greater than positive or negative 5 halves. Alright, so because I could go ahead and take the square root of 116, I left them alone. So my answers are positive 5 halves and negative 5 halves, but this is an inequality. So here's what we're going to do. I am going to draw myself a little number line real quick. Alright, and I've got a positive 5 halves over here, and I got a negative 5 halves over here. Alright, and I'm going to pick a test point. I'm going to pick 0 as my test point, because I love multiplying by 0. I'm just going to plug that into the original equation. So, 16 times 0 squared is greater than 100. Alright, so 0 squared is 0 times 16 is 0, so we got 0 is greater than 100. Is 0 greater than 100? The answer is no, it is not. So we do not want the area in between, which means I do want the areas on the outside. So my final answer, if I want the area to the left, which is this side to here, I want where x is less than negative 5 halves. I also want this area over here, so I'm going to make this in an or statement. So it's x is less than 5 halves, or negative 5 halves, that is, or x is greater than positive 5 halves. And that would be my answer. It'd be a two-parter. At this point, I would try and do the rest of these and see what you can do, and then come back and watch the rest and see how you did. Alright, number 35, hopefully you've done this one already and now you're just checking your work. So I'm going to burn through this real quick. I'll start off by dividing by 9, so we get x squared is greater than 16 over 9. From here we can take the square root of both sides, and we get x is greater than, remember when you take the square root to get rid of a square, you have two answers, a positive and a negative. And I can take the square root of that. Square root of 16 is 4. Square root of 9 is 3. So I get x is greater than or equal to, greater than, plus or minus 4/9. So here we go. There's my number line. I got negative 4/9 over here. I got, make the negative side a little bit more obvious. And I got a positive 4/9 over here. And I just need to pick a test point. Remember, these are opposites all the way across. So I'll pick a test point 0. Plug it in. So, 9 times 0 squared is greater than 16. We're going to see if that's true. 0 squared is 0 times 9 is 0 is greater than 16. That is not true. So therefore, we do not want the area in the middle, which means we want the area to the left. I put a hole here because it's a greater than sign, not a greater than or equal to sign, and we want a hole. We've got a hole there on the right, and we want the area to the right. And again, it's two sections, so you need two answers. So I want less than negative 4/9, so x is less than negative 4/9, or x is greater than, this area over here, positive 4/9. And those are your answers. Okay, these two have x squareds and x's, so I can't solve these simply by taking a square root, but here we go. First of all, move everything to the left. So x squared minus 15x minus 34 is less than or equal to 0. And I could use my quadratic equation to solve this, but in this case, I'm actually going to factor it because it's factorable. Two things that multiply to the left are x times x. Two things that multiply to the right are 17 and 2. In this case, it is a negative 17 and a positive 2, because negative 17 times 2 is negative 34. Whoop. And negative 17 plus 2 is a negative 15. Alright, set them equal to 0. X minus 17 equals 0, so x equals 17. And x plus 2 equals 0. So x equals negative 2. So those are my two variables, my two values. Again, we got to pull up our number line. And then we'll put up negative 2 and positive 17. And if you don't remember, what's Mr. Hunter's favorite test point? 0. So we're going to test 0 and see what we get. So you can use whichever one you want. You can use the original, or you can use the one we just moved over. It really doesn't matter which one. I'm going to use the original. Why not? So we've got 0 squared less than or equal to 15 times 0 plus 34, and we're going to see if this is true or not. 0 times 0 is 0. 15 times 0 is also 0. Plus 34 is a positive 34. Is 0 less than 34? Yes. So in that case, that means since this inequality worked, we do want this area in the middle, so we do not want the areas on the outside. And it's a greater than or equal to sign, so we want filled in spots. We want all this area in between. And since this is only one area, we don't want to say this or that like we did on the other two. We can just say negative 2 less than or equal to x is less than or equal to positive 17. And how this reads, if you're not used to it, basically what this says is negative 2 is smaller than x. This point right here at negative 2 is smaller than these x values in the middle. At the same time, x is less than or smaller than 17. All these things in the middle are x is smaller than 17. That is how you read that statement. Last one. Here we go. We've got x squared plus 10x less than or equal to negative 21. Just again, get everything to one side. X squared plus 10x plus 21 less than or equal to 0. You could use your quadratic equation, or this one is also factorable. I think it's x plus 7 and x plus 3. 7 times 3 is 21, 7 plus 3 is 10. Yes! That's how that one works. So we've got x plus 7 equals 0, so x equals negative 7. And we got x plus 3 equals 0, so x equals negative 3. Alright, so those are my two roots. Let's see, where is the actual graph less than 0? So I got negative 7, negative 3, and we can still test 0, which is over there. We can still use 0 as our test point. Nothing wrong with that. And I'll do that right. So it's 0 squared plus 10 times 0 is less than or equal to, was it negative 21? Yeah, negative 21. So here we go. 0 squared plus 10 times 0 is all 0. Is that really and truly less than negative 21? No! So at that point, the 0 does not work, which means my outsides do not work, and my inside does. So we can state this just like the last one. Pause it, see if you can do it on your own. But negative 7 less than or equal to x less than or equal to negative 3. And I'll explain it again. Negative 7 is less than or smaller than all of the x values. Negative 7 is smaller than all of these values right here. Negative 6, negative 5, negative 4. It's smaller than all of those. And at the same time, x is less than negative 3. X, all these values, negative 4, 5, and 6, are less than the endpoint, negative 3. That's how the statement reads. So that is your final answer.